The issue at hand is the contamination of freshwater sources with heavy metals, posing a significant environmental and public health concern. Heavy metals are toxic substances that can have severe detrimental effects on aquatic ecosystems and the organisms that rely on these water sources. When heavy metals contaminate freshwater sources, they impair water quality in several ways. Firstly, heavy metals can alter the physical properties of water, leading to changes in its color, odor, and taste. These alterations make the water unappealing and unpleasant for consumption and other every.
box prototype, which will be developed into the spectrometer. So this box is created by using SketchUp and also by using the black material in order to prevent light from penetrating into the box and interfering with the reading that will be obtained from the sensor. So as you can see, this box has 15 cm length, 13 cm width and also 6.5 cm height. This spectrometer prototype, or we call it as SpectraSense, has 5 major parts which belong to a certain major component. So the first part of the box is reserved for the microcontroller that will be attached to the wall of the box. So you can see it will be attached to the wall of the box right here. The second part of the box is the sensor part, which is located right here. The characteristic of this part is that it has a width of 4.2 cm, a length of 0.6 cm and a height of 1.0 cm, which is the sensor is perfectly fit in the it. Besides, the sensor used in this project is a sensor from the SparkFun company, the AS7265X sensor, also known as the SparkFun Triad, which will be shown later in the next part. Next, the third part is the space to place the cuvette, which has 1.7 cm width, 1.7 cm long and also 3.5 cm height. So lastly, the fifth part of the box, which is the major part, is located right here, where this place we will put a power source, which is power bank. Next, for the cuvette, it will be placed 1 inch away from the sensor, as already stated in the datasheet provided by the SparkFun company, to ensure the reading that will be obtained from the sensor is accurate. Next, the PCB board will be placed 1 inch away from the cuvette, where this PCB board contains 3 different light sources, which is visible LED, UV LED and IR LED. Next, the PCB board will be placed 1 inch away from the cuvette, where this PCB board will act as an external light source, which is contain 3 different light sources, which is UV LED, IR LED and also visible LED. So firstly, we will go through the microcontroller, where in this microcontroller we will use 6 pin, which is 3.3 volt, 1 ground on the right side, SDA pin, SCL pin, digital 8 pin and also 1 ground on the left side. As the first part of the sensor, we will use 4 pin, which is SCL pin, SDA pin, 3.3 volt and also ground. So in this sensor, we have 3 separated sensor, which is AS72651, which is we will use for visible light, AS72562 for UV light, and also AS72563 for IR light. Lastly, in the largest part of the box, we will use power bank to supply power for the sensor to function. So for our simulation, we will use 3 heavy metal, which is zinc sulfate, copper sulfate, ferrum sulfate. How we conduct this procedure is by placing each of the sample in different cuvette to obtain single reading from each sample. So we begin the experiment by ensuring all of the LED is turned off, because we do not want any initial reading obtained before the box is sealed. So we begin the experiment by placing the empty cuvette into the cuvette place, and the box is sealed. So by turning on the LED, we will obtain the initial reading without sample. Next, we will use the second sample, which is the copper sulfate, and we insert it into the cuvette holder and shut the box. So as you can see, the readings also changed from the original reading without the sample. So for the last sample, which is the ferrum sulfate, and we insert it into the cuvette holder and also shut the box. Same goes to the ferrum sulfate. The readings also have their own changes compared to the original without the sample.
Setup untuk absorbance and transmission. Mula-mula sekali, ni light source ni akan sambung dekat input ni, and output ni akan sambung dekat spektrometer. Lepas tu, sebab kita guna spektrometer untuk UV-Vis, wire yang diguna wire warna biru ni. Kalau VIS NIR, wire yang diguna wire yang ni, yang bersih ni. Lepas tu, mula-mula sekali kena letak dalam ni cuvette yang kosong yang tak ada apa-apa sebagai dia punya reference dulu. Lepas tu dekat light source ni pastikan power dia on, shutter pun open. Then untuk dekat ocean, lepas tu spektrometer ni pun sambung ke USB ni, kat komputer ni. Lepas tu buka ocean view, then pilihlah kita nak absorbance ke apa ke. Ni absorbance, connect.